Hello everybody. In class we've been talking about integrals, which is we find out it's the opposite of taking a derivative, it's taking the integral. So what I'd like to discuss in this video is first of all some quick little techniques for finding integrals and most importantly how to use the calculator, the graphing display calculator, to check our answers. So the first thing we need to do here is recognize that this is a quotient, and there is right now no reverse quotient rule, so I don't know how to deal with it as is. So I'm going to have to do some cosmetics. So the first thing I acknowledge is that the denominator should be written in power form. I got 5 halves because this is x to the 2 times x to the 1/2, and God said when you multiply numbers of the same base you add the exponents, so 2 plus a half is 5 halves, or 2 1/2. The numerator is unchanged. So now what I'm going to do is distribute. That is to say, I'm going to divide x to the 5 halves in each case. That's the same as subtracting the exponents. So 2 minus 2 1/2 is going to be negative 1/2. And then we have 1 minus 2 1/2, that's going to be negative 1 1/2, which is 3 halves. And x to the 0 minus x, never mind. So there we'll get at 10x to the negative 5 halves. Now this is the integral of a sum of 3 different expressions, so technically speaking, even though a lot of people don't write this middle step, what I'm really doing is I'm integrating each individual statement separately, and then I'll just add the results together. I did also take the negative, brought it out, so we're subtracting the integral of this stuff. But x to the negative 1/2, remember to integrate the power has to go up, so the new power is going to be x to the 1/2, and then we divide by the new power. Dividing by a half is like multiplying by 2. Here again, x power is going to go up 1, so negative 1 1/2, go up 1, we're going to be at negative 1/2. Then we divide by negative 1/2, so the negative becomes a positive, and the 4 becomes an 8, because there are 8 halves in 4. Finally here, the power is going to go up 1, so from negative 5 halves it'll become negative 3 halves. And then we divide by negative 3 halves, which is like multiplying by negative 2/3, so that's where that comes from. And the rest is really cosmetics. There's 2 things I'm going to do here. I'm going to multiply the 10 and the negative 2/3. That's pretty standard. But the other thing is I find the lowest power, negative, this is 3 halves, is the smallest power out of all 3 of these. So I'm going to divide all 3 of these terms by x to the negative 3 halves and factor it out essentially. You can see what that does, and you can pause right now to make sure you understood what just happened there. But if you look at 1/2 minus 3 halves, or minus a negative 3 halves, which is plus 3 halves, is 2. 1/2, negative 1/2 plus 3 halves is 1, and negative 3 halves plus 3 halves is 0, so it's x to the 0 here. Anyway, this being a negative exponent, I put it back into the denominator and put it back into radical form, which can alternatively be expressed this way. So now the issue is, do I know how to check using the graphing calculator? So to do that, we're going to have to take a quick look at the graphing calculator, and I want to point out a few things. Already entered in here, I have the derivative of y1. Now notice there's nothing in y1, and then I also have the given function is actually the third statement, y3. So here's the logic that I'm going to use. If I did anti-differentiation to find the integral, then if I took my answer and I differentiated my answer, I should be back where I started. In other words, the derivative of this should be this. So I'm going to make the calculator take my answer, take its derivative, and the derivative should be what was given. So all I have to do is put in my answer, which parentheses for the numerator, 2x squared plus 8x minus 6 minus 2/3. So that's the same as subtracting 6 and 2/3. Alright, so that is the numerator. Divide that by x squared of x, square root of x. Make sure that's all right. Get out of there, close the parentheses. Okay, so that's my answer, and again, if I take my answer, I take the derivative of my answer, it should be back to the given. So what I'm trying to do is to see if the derivative of my answer matches the given function. So I could actually take y1 and unhighlight it because I'm really not interested in that. And then I go to second table and I explore to see that all of these numbers in black match all the numbers in red, and they do, which means then I've found the correct integral because the derivative of my answer takes me back where I started. So that's the trickiest part for students, is to make sure that they're using the proper logic and everything else. We've talked about it in class. If you need to know how to use or how to get the derivative and do those other things, just ask. But in terms of the logic, you take your answer, you take the derivative of your answer, and you take the given function, and you check to see that the derivative of your answer matches the given function. Hope that's helpful. Have a great day.